Hokie dokie. In this problem, they ask us what is the global minimum of the function f of x on the interval -2 to 2. So the idea is if we say graphed this function f of x from -2 to 2, what would the absolute lowest value be? And it might be at one of the endpoints, either -2 or 2, or it might be somewhere in the middle if it hits some low point like that. And so that's our goal, is to identify what that value is, what that minimum value of the function, in other words, the y value is. So the first step we will take is finding the derivative of f. So finding f prime first will help us find our critical points, our possible locations for maxes or mins within the interval -2 to 2. And then we'll talk about what to do from there. So derivative of fractions like this, we can just treat the top like usual, taking the derivative and then just leave the 3 on the bottom. 2 is a coefficient, it stays out in front while we take the derivative of the inside. So far we have 3x squared over 3 plus 2 times 2x over 2. And really the rest are just constants, so everything else would just go to 0. So now let's simplify a little bit. 3 over 3 goes away, 2 over 2 goes away. We are left with x squared plus 2x. This is f prime. When finding critical points, we want to set f prime equal to 0. And the goal is to solve for x. And when we have some x squared scenario like this, we usually want to factor. So pulling out an x, which they both have in common, we are left with x plus 2. Now we set each of these factors equal to 0 and solve for x if need be. And we get x is -2 and x is 0. So these are our critical points, or possible locations for maximums or minimums. And so we'll kind of keep these values to the side, or kind of identify them as important possible locations for our global min, which is what we're looking for. The other possible locations for our global min, like we mentioned at the start, are at the endpoints, -2 and 2. And so -2 and 2 will also be included. And as you see, there is the overlap with -2 being one of our critical points, as well as one of our endpoints. So in this case, we don't need to write it down twice. There's no need for that. So we will just, now, if we know that these are the 3 possible locations for a global minimum, our critical points and our endpoints, we will just plug these values into the original function f. And I may swap these around to be at least in order here. So we're finding f of -2, f of 0, and f of 2. So plugging these values into the original, and all we're looking for is which one is the smallest y value, or smallest f value. So let's open up Desmos and plug some stuff in. So starting with plugging in -2 to the original function, we have -2 cubed over 3 plus 2 times -2 squared divided by 2 minus 2, and then plus 8 over 3. So we have 0 for the first value. I'll go ahead and write them as we go here. So 0 for f of -2. Now let's go ahead and do +2, because we can do that by just taking away the negative from each of the x values. So I think that should be it. That's 5.3 repeating, and that was for f of 2. I'll just do 5.3. And then f of 0. Well, let's look at what we have here. We could just, I was about to say, a lot of stuff will just zero out, and so we'll not be left with much, but just replace the 2's with 0's, and we get -1.3 repeating. So again, the question is, what is our global minimum? So we are looking for the smallest y value that we found, and that is -1.3 repeating. as a decimal, you could try out different options here to see which ones actually match, or which one actually matches negative 1.3 repeating. But in this case, that should be negative 4/3. And so our answer is C. All right, I hope this process makes sense. We find the derivative, set it equal to 0, find the critical points, and then we plug those critical points as well as any remaining endpoints into the original function. And because they ask for a global min, we are looking for the smallest y value. So if we apply that process here, instead to find the global max, let's see how it goes. Finding the derivative, we get 3x squared over 3 minus 2x minus 3, set it equal to 0. Might want to cancel out these 3's. And in this case, we're back to typical factoring, which numbers add to negative 2 but multiply to negative 3. So we have minus 3 plus 1. Setting each of these equal to 0, we get x equals positive 3 and x equals negative 1. These are our critical points. Our endpoints are negative 3 and 3. So again, a little bit of an overlap with the critical points and the endpoints. But we still want to include all of them. So these are our possible locations for the global max. So now we just plug in f of, we plug in negative 3 to f, and we plug in negative 1 to f, and 3 to f. All right, so opening up Desmos. Starting with negative 3. Minus negative 3 squared, and then minus 3 times negative 3. And we get negative 9 for the first one. And now moving to negative 1. We get 1.6 repeating. All right, now we want positive 3. And we get negative 9. All right, so going back to what we are looking for, again, we are looking for a global max. Therefore, we want the highest y value that we found. So 1.6 repeating should be 5/3. Obviously, no negatives since we got a positive value, and then all you'd have to try is 10 divided by 3 or 5 divided by 3 to get 1.6 repeating. All right, I hope this process makes sense. If you have any questions, please let me know.